Okay, folks, I'm probably going to do two videos for this lab this week in exploring normality, and I'm hoping to break down some key concepts as they relate to a normal distribution. Okay, so you know, first of all, the idea of the normal distribution, we'll talk about this in class. It relates directly to the concepts of the mean and standard deviation. So you really have to have a strong grip on what we mean by standard deviation, right? It means, on average, how far an individual observation might be from the mean. Okay, so just to let's get this party started, I'm going to real quick make a histogram of the men's heights. I know the directions say, do the women first or men, but I just want to kind of do a crash course here, and we can, make this lab our own if it's too complicated to get some of the graphs to look exactly like what you have here. Let me see if I can find that one. Oh, where is it? Must be off my screen, so I can't really get to it right now. But the one with the histogram and the normal curve plotted right on top of it, that might be a little tricky. So I'm going to show you as we unpack the concepts how to get all the graphs, but we can sort of make them our own and hopefully understand the concepts we're dealing with. So I'm just going to try to make the histogram as easy as possible and go to Insert. Up at the top here, we click Insert, and then if I go here, I can get to all my charts real quick. So to get the recommended, we click on this tab that says All Charts, and let's just go grab the histogram and see what Excel sort of makes for us automatically. So I'm going to click OK, and it automatically makes this histogram, which is not exactly like the one that you have in the example with the female heights, and it doesn't give midpoints, and the midpoints are kind of key to how I want to create that normal curve. But let's just observe a couple things first. All right, I'm going to hit equals up here, and I'm going to type in average. So I just want a basic average, right? So I double click on that. What do I want the basic average of? I want the basic average of these heights. Okay, oops, I'm going to click on B. Well, that might not be what I want to do. I'm going to click on B, highlight the whole thing. Okay, let's try it again. Actually, this will be a good chance for me to use a shortcut that I botched up last week that I didn't do. I want to get the average of this whole list here of men's heights, right? So I'm going to click here, and if you scroll down now, and this is what I couldn't remember a couple weeks ago in class, went blank. When I click, if I hold down the Shift key and then click on this bottom row, that's what streams down there. More to come on that. I'll revisit that. It'll make more sense. So it gives me the average male height, 177.7453. So because this histogram is pretty symmetric, we talked the first week of class that the mean and the median should be about the same. If we had a distribution that was, let's say, skewed right, where you just have most of the observations out to the left, but then a few really large observations, that's going to make the mean larger than the median. But here, since it's pretty symmetric and mound-shaped, the center of the distribution is right around the mean. 177.2, 177.7. That's about where this data is centered. And if we calculated the median, we'd probably get a pretty similar estimate. Just for the heck of it, let's see if I can get a median over here. Yep. So if I want to do a median for those same numbers, grab them. I'm just scrolling down quickly. What did I get for median? Yeah, 177.7, 177.8, pretty close. Okay, so if the mean was a lot bigger than the median, usually your data is skewed to the right, or there's some outliers to the right. If the mean's a lot smaller than the median, you're skewed left. You have some very unusually low observations. Okay, but this mound-shaped symmetric distribution here doesn't give us any of that. So I'm going to, if the mean is a reliable measure of center, then our standard deviation is a very good measure of spread, and it relates really importantly to this normal distribution. So I'm going to hit in equals, remember STDEV, right? And we'll use sample standard deviation. Okay, pretty much always assuming I have a sample. So if I click here, Scroll down real quick to the bottom. Hold the Shift key and click. I get my whole list. Let's press enter. All right, so I have a standard deviation of 7. All right, so this, sometimes I just call this the 68, 95, 99.7 rule, but it's also called the empirical rule. It basically means this. If you start here at the center at the mean, okay, and I subtract a standard deviation, so that would put me where? The middle's at 177, and I subtract roughly 7, I'd be at about 170. And if I add 7 to 177, I'll be about 184. So what that means is from 170 to 184, I should see about 68% of all my data. And just with the eye test here, that seems about right. It looks like that'd be about 70%. Okay? The next piece of the empirical rule means if I subtract 2 standard deviations, so 177 minus 2 times 7, so 177 minus 14, where does that put me at? 163, way down here. And then add 14 to it. Where does that put me? 191 up here. That should be 95% of all my observations. See it? It sounds about right as well when I look at this. So if I look at a histogram like this that's mound-shaped and symmetric, it's usually a pretty safe assumption that I can assume the data follow a normal distribution. And that's huge for us in making statistical inference because then, for example, if an observation falls 3 standard deviations above the mean, well, we can easily say that that's a really significant observation, right? Like in terms of men's heights, if somebody's height is 3 standard deviations above the mean, we're going to say that's pretty unusual, okay? It's not likely that we are going to observe that. If you saw a person that was that tall, you would notice them. They would stand out to you, okay? And that's a big piece of statistical inference, determining whether or not something is significant or not, okay? So the first part of one of the activities here is can we fit a normal curve to this distribution, okay? And you want to make sure you have your Word document handy because one of the formulas that I'm going to pull from here, the normal distribution formula, I'm going to pull right from the Word document. But the first thing that I want to do is get the midpoints, okay? So what I'm going to do over here is just create a extra column here, and I'm just going to call this column midpoints, okay? So let's take a look down here. The first midpoint would live in between 157.2 and 161.2. How do I get that? Okay, click in this cell. You can just click equals, all right? And then I can just do the math. I'm going to do 161.2. Oops, let's start with the parentheses. 161.2. And then I'm going to add that to 157.2. And then what I want to do to get that midpoint is divide that by 2. That'll find me the dead middle of that bin, right? 159.2. All right, hopefully this makes sense in a second as I do a couple more. So I'm going to hit equals again, parentheses, and now I'm looking at this next bin, 161.2 to 165.2. 161.2 plus 165.2, right? Close that out, divide by 2. All right, now what do I see? I see a pattern. It's going to be really easy. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bins. All right, there's 11 of them. So this list ought to have 11 numbers in it. What's happening here? We're adding 4 every time. So just keep adding 4 to the previous number. Okay, so this would be 167.2. Add 4 to that, and we would have 171.2. Let's add 4 to that, so we're at 175.2. 179.2. And now it all starts to start over again, kind of, right? We'd be at 183.2, right? 187.2. 191.2. And finally, I think I need 2 more. 195.2. Yeah, and then I need 1 more. I need to be at 199.2. Okay, so can everybody see that 199.2 would put us right in the middle here? All right. Okay, so now over here, I'm going to need my y coordinates that I'm going to match up with these. I'm just going to call them y coordinate. Hopefully that makes sense. All right. But basically, this y coordinate is going to be the probability of these values occurring if the distribution is normal with this mean and this standard deviation. Okay, and this will make a little bit more sense in a second. So the formula, this is on the very first page of the Word document that goes with Lab 3. So I'm hitting equals. I start to type in norm, and that norm dot distribution comes up. Okay. So I'm going to double click on it. And remember what it says in parentheses, x, and then the mean standard deviation, and then false. So I need to tell Excel, hey, get the x from right here, right next door. That's where x comes from. So we click on that. Okay. I'll put in a comma. And now I enter my mean and my standard deviation, which I stashed over here. So my mean is 177.7453. My standard deviation is 7.183629. I should have made this larger for myself. And it's a false. Oops. False. Okay. And I click enter. So it's finding, look, really small probability. It's not really likely to observe someone this short in height, right? This is the lower end of the height. It's not real likely. So what do I want to do now? I want to click up here. I want to repeat this formula down. And what we can do here is we can just grab this box here and drag it down. That's the shortcut I showed you all in class. But if the list was like 20,000 long like it was before, right, what do? I come up to this box and I hit Control-C. So that tells Excel, hey, copy that formula, right? What I just did up here, referencing the guy next door, I want to do that over and over again. Then, holding the Shift key, I come to the last cell. Like if these were 20,000 long, you scroll down to it, it would take a while to do it the way I just did. But go down to that last cell with the Shift key down, click, and now we can hit Control-V, the shortcut for paste, and we get it done much the same way. Okay? So that's what I wanted. So finally, what do I want to do? I want to scatter plot this. Okay? I'm going to make a scatter plot of this, but I don't want to see actual points. Right? So watch what we do. We grab the two lists, so that way Excel will have a heads up of what it is I'm trying to do. I'm going to go to Insert, go to All Charts, all right, and I want a scatter plot, but check it out. The way I want to scatter plot this is not plotting any points, just give me a straightaway line, right? So check it out. We click OK. All right. So you look at this, and we kind of want to fit it to this scale, which we don't have. That's an easy enough fix. The reason it doesn't look like that is because it's not scaled like this. This thing basically goes from like what, 157 to 200. So let's try to switch it up. Come down to the axis here, right click on that axis, okay? And let's just format the axis. All right, let's tell Excel, like, look, don't start at 0. There's nothing happening out there. How about if we start at 150, okay? And what if we go to, instead of 250, 210? Or even if we do it exactly pretty much the way we have it here, let's start at 157, and let's go to 201. All right? Now it kind of fits perfectly. Right? They're on the same scale. And when you look at this, right, this is a density curve that mirrors this histogram. Definitely looks pretty normally distributed. It definitely looks like it follows that 68, 95, 99.7 rule, right? If I go a standard deviation this way and this way, 68%, 95, 99.7, okay? All right, so stay tuned. I'm going to break this into two videos. The next video is going to be the normal probability plot, but I'm basically going to start from right here. Okay, I'm just going to make a new video out of it.